Welcome, everybody. I'm excited to announce our speakers, and we've got Markus and Oscar, who you've already heard a little bit from today, so now we can tell that they're world-famous DockerCon speakers as well. So beyond that, I'm really just going to turn the time over to them. So let's go ahead and give them a round of applause and turn the time over.
Hello, I'm Markus from Finnish Railways. Probably you noticed me in the keynote, and we are going to dig a little bit deeper about the little modernization exercise we did in Finnish Railways, and I'm really hoping that we could give you some ideas or thoughts or lessons learned if you are struggling with the same kind of problems that we have been struggling in Finnish Railways with our application modernization. Right, so you heard this one in a keynote, so I won't be digging very deep. And we have those main business units and those supportive units, and you saw this, so we can probably skip this one. But let me tell you about the diversity we are facing. That the problem is that those divisions which were in the first slide, they used to have their own ITs in the past, and that has led to a sort of a problem that nobody has looked up to the big picture. So there has been lots of applications developed and different ways, and no structure in there, and there are lots of applications, and they do overlap and so on. And sometimes it feels that our company is 150 years old, and it feels like some of our applications are that old, especially those mainframe ones. So it's a very complex environment, and we had to tackle it somehow. Right, and these the business drivers which led to this is the usual ones, which I mentioned also in the keynote, that the bang for the buck is the main one. It has to be cheaper in nowadays environment, and of the quality and time to market. Those were the main business drivers, but also we had a few IT drivers, which was we wanted to have the common application platform for everybody and unified architecture, and those were the big things what we are looking after. And then we decided that we would like to change to open source solution. We had a lot of proprietary solutions in our old environment, and we want to switch to open source ones. And then we want to adopt the microservices, and of course that brings us to DevOps also. Those were the main IT drivers for this change. All right, and now I'll go quickly through this, that what has been actually done. So everything started with the renewal of our reservation system, which was mainframe-based, and we then decided that we would rewrite it and do it with microservices. And then we did a lot of analyzing about our options, with what product we would use, and we came up with the conclusion that we would use Docker in there. So basically that was the point when everything started with this. And after that, we had to bring in with the DevOps platform to have those tools which is required. And then was this migration business case created, which I told about in a keynote also. So, and also this thing needed a lot of other changes too. We had to revamp our AWS structure. We started basically with a very simple one, and then we just stopped and rethink that, and we rewrite it all over again, and we changed the account structures and changed it to the IAC. Now we do have our environment as a code, so that's a pretty cool thing for us. And also the Docker platform implementation started about over a year ago. And when I created this slide, I actually looked at what have been accomplished during this year, and I think that we have done a lot in a really tight time frame. So these are just the main points there, and I think that everybody who's who's been working with companies like us that has the old sins, so to speak, that the old environments and so on, and you have to navigate through those that it creates some problems in its own. The development phase has been, and the pace has been pretty incredible. So the main points in this year has been that, of course, we started those migrations pilots earlier this year, and then also we developed those new applications. And the first one went live in the Docker platform in June. That was the commuter traffic, and these are the new ones. And then the reservation system, which started this whole thing, that went live on August. So that was basically, we popped up our champagne bottles and so on. So that was a really big thing for us. So now we have those migration pilot apps went live, and the migrations has been started in a really big level. So that's basically what's been doing, and now that Oscar can probably tell you more about what's actually been doing in the platform.
Yep. Thank you, Markus. Yep. So let's have a closer look at what we call the platform, right? Because it was very clear that Docker Enterprise Edition was going to be the way forward for running the applications, whether greenfield microservices or the brownfield migration stuff. Even though we had clear business drivers, clear IT drivers, we still had an additional set of goals, drivers, very specific around, it's a platform. Markus, the Finnish rail team, wants to give a consistent experience to developers. It needs to be a unified experience. So we actually had our own set of goals around, first of all, from a technology perspective, let's be consistent, right? Common runtime based on Docker. You can put whatever you want in your containers, but it's going to be Docker, right, for everyone. It had to be unified, same idea. So the same common underlying components, the same capabilities, regardless of the technology you want to put in your containers. That was a very, very important driver. And of course, it had to be automated. One of the biggest IT drivers for Markus and the team was, let's do this fast. Let's reduce time to market. So we spent a significant amount of time making sure that once you have your things in a container, you can go to production as effortlessly as possible, as fast as possible, in a most automated manner as possible. So we actually had spent some time doing that. So obviously we're here. So the platform was built on Docker Enterprise Edition. We at Accenture, we had been working with Docker for some time. We had a reference architecture on what are the key building blocks, the key capabilities we need in a container platform for it to be successful. That's what you're seeing now on the screen. But then, to be honest, Docker is a very robust platform. It's enterprise containers at scale. However, we did realize that there were a few things here and there that we still needed to add as third-party products. For example, in the areas of logging, right? It's easy. You get your container, make sure your logs go to std out. That's fine. But then, what do I do with my logs? Where do they go? How do I capture them? How do I make them available? So, for example, we introduced things like Elk, running Elastic's cloud managed service for running our logs from the containers. We had the same thing on the monitoring space. Traditional monitoring tools don't fit that well in the container space. All the Xenos and all these Zabbixes of the world, they're pretty good solutions, but they're not ready for containers. So we went and looked at container-native solutions. We settled on Sysdig. We've been very happy with the capabilities they provide for our containers in terms of introspection and visibility of what's happening in the container. So really, really exciting stuff. And then we'll see in a second, running on Amazon. We had requirements for shared persistence, right? So we're leveraging EFS for some things. We're storing all the container images on the S3 backend using DTR. So we actually made the best of additional third-party components to enhance the platform that we get from Docker E, deployed on Amazon Web Services. I mentioned it before. This is a single platform regardless of what you're running, right? So we have non-production workloads. We have the development clusters, hundreds of containers on a regular basis, a lot of churn coming in and out. So really, really a lot of non-production workloads. In the middle, we have the greenfield workloads, microservices. These are cloud-native, container-native things that we're running on the platform, designed to be put in a container. So it's typically Spring Boot stuff, really, really friendly towards containers. At the same time, on the same platform, we had the legacy workloads that we have been migrating over the last few months. So the Amazon stuff, we've been, so from the very beginning, it was clear this was going to be running on Amazon. We made a consistent effort to make sure that the platform and Docker EE leverage the Amazon services and capabilities. So we have running on Island, we're running our masters across, or our controllers across the availability zones. We have the workers across the 3 availability zones, ELBs, all the S3 buckets for backups. So we have our Amazon wizard sitting here in the front row. We made a consistent effort to make sure that it was leveraging Amazon and that it was as fully automated as we can. We actually spent some time writing the Terraform scripts. We can stand up a full Docker EE cluster with Amazon integration in about 20-25 minutes from scratch. So that was a really, really great effort. From the cluster perspective, so it's a single consistent platform. However, there's actually separate clusters. We have a development cluster. It receives all the CI workloads. Anything coming out of Jenkins, it's dumped in there. Teams can test it. If it's there for a minute or an hour or a month, it doesn't matter. It will be there running. We have then a separate cluster for testing purposes. We chose to keep them separate because we've had some challenges upgrading Docker. We had situations where we would actually have the platform offline for like a day or two while fixing some of the upgrade issues. So at the end of the day, we thought it was a better decision to actually split it a bit more so that an upgrade problem wouldn't knock out all our non-production environments just like that for days with teams, right? So it doesn't help that we have state-of-the-art platform if it doesn't work for 2 days. Teams were not really happy when we had that. So we actually split that. As a recommendation towards you guys, if you're thinking of running Docker, I would suggest you look at also, still providing the same capabilities across physically isolated clusters so that you can handle all these upgrade issues in a much more segregated manner. So we have a development cluster. We have a process that is orchestrated through our CI server to promote the images from DTR to DTR. These are clusters, these are full clusters, each one with its own UCP, its own DTR, its own Amazon resources in completely separate VPCs as well. So they're fully separate, they don't see each other. So we just make sure that we can push images from one UCP to the next, from development to test to production. There are 2 production clusters. This is a fairly recent development, and the idea is that there's always one that is live, running all the key production workloads, serving customers, hundreds of thousands of requests per day. The team can flip a record in the ELB and then switch to a full new cluster. We make sure we deploy whatever needs to be running, and then we can be up and running in case of a production failure in a matter of minutes. And again, in a fully separate VPC, full separate cluster, but deployed and built with the same automation scripts we worked on with Terraform. So we're running on Docker EE. From our experience, so this is a full multi-tenant platform. We're running multiple teams, running a broad variety of workloads. In reality, we don't even know what the teams are putting in there. They're given a choice, right? You can put your Spring Boots, your JBoss, your Tomcats in the container. They get a consistent experience. They get logging out of the box, metrics out of the box, monitoring out of the box. It's all there, regardless of what they do. And that's been through the multi-tenancy capabilities we get from Docker EE. So we have, each project has its own organization. They have at least a technical user. We have linked UCP to Active Directory. So basically the process for onboarding new teams and onboarding new users to Docker EE is pretty painless. To just get the users added to Docker to AD, and then they'll flow automatically into Docker EE. That's really, really seamless and straightforward. We provide each team with their own HTTP routing mesh resources. We have a big subdomain. Each team gets its own piece of the subdomain, and then we let Amazon Route 53 take care of the routing, and then HRM, when the request hits the HRM, then it takes care of routing it to the right container on the platform. And then teams can choose to structure their own subdomain around whichever different naming conventions that they would rather follow. Most of them just use one piece of the subdomain is the environment, the other one is the version, the other one is the application name. So they can do whatever they want as long as they stick to our guidelines. Teams, in terms of access control, teams can manage each one of them their own resources. So stacks, services, networks, everything's been standardized. We have I'll show you later, We have a set of guidelines instead of best practices that teams need to follow as part of our platform guide. But they're given full freedom to manage their own things. If they need 5 networks, they can get them. If they need just 1, that's totally okay. They do whatever they need to do. One specific requirement we had around billing is that within the Finnish rail, different business groups wanted to be charged differently based on the consumption. So it's not that we have, it's one big platform, but it's segregated by business unit. So then different containers, they use different engine labels to deploy to the right engine, so that then when the time to pay to Amazon comes, then we know who's been running on what. Initially, it was a bit rudimentary because we're using engine labels. We have some plans now to move to the node RBAC. So basically, using built-in capabilities, we can ensure that users are deploying to the right nodes that they have access to through the RBAC. And this was a great feature that we saw. We were very happy to see in 1706. So really, really cool stuff. And finally, secrets management. So looking at the legacy wall, we had to actually mess with configuration files, and there were always problems with partners and vendors deploying the wrong config file. Then my application doesn't work. Why doesn't it work? Well, you put the wrong file in place. Now in the container world, again, from a consistency perspective, everyone uses secrets management to store their configurations. Even if it's not a secret, we recommend that they put it there, because then Docker takes care of making sure it's available to the right containers at the right time with the right security level. So it's a great feature. We had to do a bit of scripting work. Modern frameworks like Spring Boot, they will happily read from whatever file you tell them to read to the environment. Older stuff, we had to do a bit of scripting to make sure the values were being put in the right place. But it's not an insurmountable challenge. You can work with that. And in terms of simplifying configuration management, it's gone a long way towards getting us there in terms of making it easy for teams to consume. We also use DTR. It's our registry. And the structure it's really similar to what we're doing with UCP. So one DTR org per team, they manage their own repositories, right? If they need 1 or 10, it's all the same to us. They get, this was a really nice feature we've been using, immutable repositories. We had some problems with teams being lazy and overriding the latest label, latest. It's not a really good practice, so we switched on immutable repository. So then they can only add new labels to that, and it made the whole process around tracking which one is the latest image, is it really the latest. It made it so much easier when we enabled immutable repositories. Scanning and signing, we were very excited about when they were delivered, I think in 1703. We haven't switched that on yet, but it's something that is in the roadmap. Especially scanning, it's really a fantastic feature. And signing, it should go a long way towards Markus and the team having the assurance that whatever is being deployed should be deployed because it's signed. So we have big plans for that. Not enabled yet, but we're very excited about taking it into use as soon as we can. Right, and then we had to enable developers, right? It's not just about making sure they have the coolest, most state-of-the-art advanced platform in the world if they can't use it. So we actually had to spend some time. No one likes writing manuals, but we spent some time doing that, making sure they understand, how the platform works, what the capabilities are, how do I do load balancing for layer 4 routing, right? I have TCP ports. We're dealing with EGBs over RMI, TCP stuff. How do I make sure my services can talk to each other over TCP? So we provided them with patterns. That's how you do it. Cookbooks. How do I manage reverse proxies? How do I manage multiple application versions deployed to the cluster at the same time? So we told them how to do it. Very simple instructions. That's how you do it. That's how the compose file looks like. And if you want to see how it works, go look at our reference applications. Right? We had a bunch of applications showing all these concepts so that all they had to do is copy-paste. Right? That's how you do it. We also provided them some base images. We actually centrally manage some of these. So our containers, they all run on CentOS. Not the thinnest, not the lightest, but everyone was familiar with it. Everyone preferred to use Yum for installing packages over, say, Alpine's APK, which doesn't always have the latest things. So we set it on CentOS. We manage it centrally. A lot of the stuff we do is on Java, so we have always an image available with the latest OpenJDK or the Oracle JDK, whichever you prefer. Base image with JBoss, because that's the Finnish Rail's choice of application server. And finally, so I mentioned the reference applications. We also have reference pipelines for Jenkins. Jenkins is our CI tool of choice. And we made sure that that's your container, you can build it locally, perfect. Now let me show you how to deploy to the cluster. Right? And all they have to do is go to Jenkins, copy job, they get all the steps out of the box, they put in place their own bundle for deployment to make sure they can access their own resources, and well, off they go. Right? So in a good day, it shouldn't take a project more than an hour to get started. Take the reference application, take the reference pipeline, get it deployed, and then they have a foundation to start building their own containers really, really quickly. So it's worked very well. So I mentioned the pipeline stuff, right? We wanted to really, again, tying this back to what Markus was saying before, provide a unified experience, a consistent experience. So this is the reference pipeline, actually. It doesn't get any easier, right? But still, we have the build steps, we have the test steps. We actually have a bunch of build nodes. We don't build on UCP. We have separate engines that are managed by Jenkins that actually are used for building, right? So anything around building a container, doing the unit test or the integration test for a container, it's happening outside of our platform, again, to reduce the churn of containers that are used for like a few minutes at most. That's been successful, perfect. We take the container, publish to our development repository, and then we have all the promotion jobs that go across, help teams go across the landscape in terms of environments to promote from development to test, from test to pre-production, from production to production, and the jobs take care of, pulling the image, tagging it with the next repository, and then push it, and off it goes. And again, this has all been pretty automated for the teams. All they need to do is take the reference pipeline, replace the right things, put the bundle in place, and off they go. This was very important for Markus and the team from an operational perspective. So as Markus was saying, they didn't always have the right levels of visibility on their legacy platform. Right? It was running on a common hardware, yes, but it was always hard to see what was happening. From our perspective, again, we made a huge effort in making sure that we have now everything in a container. We know what's inside. We know where it's running. Let's make sure we know and provide developers with the right level of access to the logs. Right? So take your container. Our guideline says, please make sure you push to std out. And then we have configured the Docker engine with the syslog driver that's captured in syslog. We push to Elasticsearch, and then through Kibana we manage access control through indexes to the different container logs. From a monitoring perspective, and actually from metrics as well, as I mentioned before, it's Sysdig. Sysdig is, for us, it's been a zero-effort tool. Deploy their agent on each node. It's the container itself, plugs into the Linux kernel, and you can start, getting any sort of metric you like. That goes to the Sysdig service. We get all the dashboards. Anything you can dream of, you will have it in Sysdig. Again, regardless of what you're running, you get metrics in Sysdig. And teams, I think they really like it. It's been a very flexible tool, and it's really gone a long way towards providing that consistent experience. And then from a resource management perspective, the idea here is that we use Docker engine capabilities to control, how much CPU can an application consume, how many shares, how much memory specifically. A lot of the services we're building are actually memory bound on the JDK, which is not always a fun thing. But we make sure that through memory quotas, we control how much they're using to make sure nothing spirals out of control, and then we start getting, the out-of-memory killer in Linux, and then we have all sorts of odd behavior. So we actually control each and every container that gets deployed to the cluster has memory and CPU limits as part of its compose files.
Yeah, I can talk through this. So those drivers and versus those what we achieved. So the time to market has remarkably better now. So basically, it used to take like at least hours with all the preparations that took before that. If you take that into the account, it could take days. So now we're done in minutes. So and nobody noticed anything. And basically, that's amazing thing, and that works like it's supposed to be working. And the bang for the buck part, now we are running at 50%. Lower costs, and that's an amazing thing for the business. They really like that one. I can tell you that any CFO will take that. And the quality part, now we have automated testing, including performance in there. So the quality has improved also a lot, and it has to be better in this world where we deploy like now we can do those in several days. So there has to be automation in place. And for the IT driver part, so we now have that unified architecture, like Oscar said. That's a pretty cool thing. Really, we are really proud of that, what we have accomplished in that area. And then we are utilizing the open source products and microservices and the DevOps are also there. So all the drivers which started this have been matched with flying colors. So that's a really amazing thing what we have accomplished here. So about the lessons learned, I thought about this. What I would like to say in here is that basically, everybody knows who has been in a very complex project that things change and you have to roll with it, kind of things that you don't expect happens, and then the resources are sometimes hard to come by, and those I don't want to list those because everybody knows that that's a usual thing in a project. I mean, every big project faces those kind of problems, but what we learned is that. We have chosen the technology, and we know it works. Other clients use it, and so if you trust it and you have tell it to your directors and so on, you have the support for them. Then go for it, and just you are on the right track. There are bumps on the road, but just believe in it. It works, and it will turn out fine. And then another thing is that how many of you are developers in here? I think. Majority is. I can tell you one thing. This is not just a technology change. This thing changes your whole organization, because all the DevOps and that stuff which you have to bring along. This is not just a technology. It goes right through your whole organization, and generally people don't like change. So this changes a lot, even if it changes to a better way, but anyway, they have learned to work in a certain way. So they have to learn a lot of new things. So that is one thing that if you are starting this change, you have to keep them in a loop, inform them all the time what's happening, and telling them that look, this is make your job a lot easier. Now you can find your logs and you can see what's actually happening with your application there. So don't worry about it and that much. And that's the really big change. If I have to change something in this project, I would definitely inform our people a lot better. So it helps in uncertainty area in your organization. And about these technical lessons, I think Oscar can cover those.
Yeah. So as I said before. It's about developers, right? We spend a significant amount of time making sure that, this is cool, containers, this is great. We had to make sure that any developer anywhere in the organization was able to use it, right? We always have developers that are more skilled than others. They can pick up technologies really quickly, but we wanted to really make sure we reached all the developers and make sure they could actually reap the same benefits we would be seeing if other skilled developers were doing it. So again, we spent some time writing the guides, we spent some time with the reference application, we spent some time with the documentation, examples, to make sure that really anybody could pick this up anytime and be able to start being productive from the first minute, right? That was a really significant effort, I have to say. But I'm hearing that they're loving it, right?
Yep.
They like it, so it's good. And then from a evolution perspective, I was now thinking, did we start with like UCP 1.1? So in the time we've been doing this, was it 1.1? 1.1. So we went through 1.1, 1.2, 1703, 1706, and that's been in time span of about a year and a half, give or take. So Docker itself is evolving really fast. So make sure that you can deal with that. Otherwise, you won't be getting the benefits of the latest features. They keep adding new features, really cool stuff at every release. Make sure you can deal with that, right? So in our case, again, we spent a significant amount of time automating the installation, automating the upgrades, right? So we wanted to make sure that whenever a new feature, a new release is available, we can be on it in a matter of hours, right? So again, make sure that whatever infrastructure you're running, whatever organization you're dealing with, that you can deal with the change, not in the beginning, because Docker will keep releasing things every 3 months. So make sure that you can deal with that.
Yep. So do you have any questions?
Thank you.
About regarding? I know that this is a million-mile high view of things, and we are just scratching the surface. But I think that we have done a really cool job in here, and we are very proud of it in our company. And I think that if we can do it, then pretty much everybody, like MetLife says that they did it, so we have done it. So I think that really everybody can do this. So we haven't had the sort of agilest of the organizations either. So, and a lot of the old sins in applications and stuff like that. But we managed to do it, and we are on the way and learning all the time. And this is very cool stuff that we are doing. We are very proud of it. So I think that you can do it also. But if you have any questions regarding the technology or other stuff, then please go ahead and ask.
Yeah, I got a question about regarding your DevOps approach. Are these teams that are now migrated to the new platform on Docker, are they really DevOps teams in the means of you build it, you run it, so they operate their stuff, or is there a central operation unit still?
We have a central operation unit at the moment. But we are pushing the way that also the guys who have developed it actually do the operations, but not yet. Not yet the full DevOps way. Any other questions? Come on. Okay.
There's a microphone.
Are you running your Docker workloads on public cloud exclusively, or do you have also? Are you planning to run them on on-premise infrastructure as well?
No, we try to get rid of the on-premise. So we are running it in Amazon, but we are planning that we get expanded to, for example, in Azure, because Docker totally allows it. But at the moment, we are running in Amazon and expanding it.
Right. Great presentation, guys. I'm just curious, how many total applications or application components have you containerized so far, and kind of what's the time period in which you did that?
As I said, that we have the reservation system. That's a whole new system, which is written in microservices. I don't actually. Do you remember how many services?
I think altogether, including all the reservation workloads and the sales system workloads, is about 20 to 25 microservices.
Yep.
And each one runs 3 instances per service. So it's about 75-ish containers for the new stuff.
And then we have migrations ongoing. The 3 are in production, and the ongoing pipeline there is about, what could I say, 10 to 15 at the moment. But 3 is in production at the moment. Okay, any other?
We're about to do the same exercise that you've been through here, where we have a lot of things to migrate. I was wondering if all the material you made in form of cookbooks and helpers and as a sample application is something that you're sharing with the rest of us, or it's just written in Finnish and for internal use?
No, we are not written those in Finnish, but they are. We used to do that also, so that crippled us some of the developments in India, for example. So we have written those in English and shared with our vendors, but I don't think that we are sharing that in public. At least we haven't talked about it, but we have been sharing all those vendors which have been plugging in our development processes, that they can get access to those, and hopefully they do read those, because there are a lot of efforts in there. Okay.
You said 2016 you decided to go with Docker. Based on which criteria, or there were other alternatives?
We did an analysis phase about the products.
We had a look at several options. I mean, we did our due diligence. We had a set of requirements and drivers for doing this. We looked at all the major container platforms. We looked at PaaS alternatives, also cloud PaaS alternatives. But given our needs and our requirements back then, Docker seemed to fit the bill better excuse me, than the other options. So yeah, we did spend some time looking at what was there.
We did an analysis, and then one factor actually was the Kubernetes thing. Now if somebody faces the same kind of thing, that it's not longer an issue.
Okay. All righty. Well, that's all the time that we have. So let's go ahead and give these guys another round of applause for their hard work.